In this video, we are going to work on rationalizing the denominator. Well, a fraction. Right, let's look at this example. Now the question says write this expression in a form that does not have surds in the denominator. So, well, how they ask the question is not nice. Actually, you could just go like, okay, I will write it without the surds, fine, and I'm going to do this. So there is no surds anymore. I'm not going to write it. It's not like that, of course. What's going to happen is that when you have a surd in the denominator, right, if it is a single surd like this one, right, you are going to multiply by itself, right? Because what happens is, we know that if we multiply a surd by itself, any surd, then it's going to be 2 times 2 equals 4 in this case, right? Square root of 2 times square root of 2 square root of 4, which is a 2. So that's an integer, that's not a surd anymore, and that's what we want. So basically, if you have a single surd, you multiply it by itself. But what happens is, if you just multiply the denominator, you will change this expression. And this is something we don't want. So we have to multiply the top part with the same surd. And basically, if you look at this expression, this is a number divided by itself. So basically, this makes 1. So we are actually multiplying this expression by 1. This is, in maths, called as do nothing, get everything. Yeah? Because basically, we're multiplying by 1, but we just get what we want. Although multiplying by 1 does nothing to this expression, we get what we want. So, let's do the work. So I know what's going to happen down there in the denominator. It's going to be, say, well, you don't even need to write this, right? You can directly write this one. That's totally fine. Okay? And then, what's going to happen here is that you multiply 3 by root 2 and 2 root 2 by root 2. So 3 times root 2, just because you cannot multiply an integer by a surd, you just write the product. So it's 3 times root 2. Plus, I just copy paste the sign here, the symbol, right? It's going to be 2, right? I write this one here. Now, root 2 times root 2 gives me root 4. So that's going to be like this, and I'm going to end up saying that that's going to be, let me write here, that's going to be 3 root 2 plus, just because this gives me a 2, this is 2 times 2, right? It's going to be a 4 divided by 2. So this is what we're supposed to do. Now, we rationalized the denominator. You can see that it is not a surd anymore, it's just an integer. Yeah? Now, it is very, very important that you don't simplify like this. You can't say this, and you can't say that's going to be, let's say, 3 root 2 plus 2. That's totally wrong. It can't be any more wrong, yeah? You can't do that. Please, do not simplify these, because, well, you have the addition here. So if you have 2 terms connected by a, did I say division? It's addition, actually. You have addition there. So if you have 2 terms that is added or taken away, right? If it's plus or minus, then you can't do such simplifications. That's totally wrong. Okay? Just keep that in mind. It's very, very important. So basically, this is the answer, right? The surd is gone, and the denominator is rationalized. Let's see another example. Now in this one, in part B, you can see that this expression is slightly different. It's 5 minus root 2, so I think you feel that there is something slightly different that we're going to do, which is correct. Now let's do part A first. In part A it says expand this expression. So basically, if you have something like this, the same terms, in one of the expressions it is a plus, in the other one it is and minus, then this is what's going to happen. Right, so it's 5 times 5, that's going to be 25, and 5 times root 2, we cannot multiply them, so I'm going to write down the product, 5 root 2. Now here, I multiply negative root 2 by 5, so it's going to be minus 5 root 2. Why? Because that's a negative number, that's a positive number. Minus times plus gives minus. And similarly, I'm going to have minus root 2 times root 2. I'm going to have minus root 4. Right? Because minus times plus gives me minus here. And then 2 times 2 is 4, so it's square root of 4. Now let's simplify this. That's going to be 25. Right? Here, these expressions are exactly the same, and one of them is plus, the other is minus, so they will cancel each other out. Yeah? And then minus root 4, well, 4 is a square number, so you can just say this is 2. So it's going to be 25 minus 2, which will be 23. So basically, the answer to part A will be 23, because the thirds are gone. The reason is that we have 1 minus 1 plus with the same terms, right? The terms are the same. It's 5 and root 2, and one of the expressions is minus, the other expression is plus. That's called as difference of squares. We are going to work this in algebra, right? But that's what happens actually. We just get rid of those third expressions and then end up with an integer. That's what we're going to use in part B. Now, basically we are going to do the same thing. We are going to multiply, right, this expression, okay? It's not going to be root 2 only, okay? It's going to be 5 plus root 2, because my aim is to get rid of the third and end up with an integer in the denominator. And that's what I'm going to do. So what I will do is I'm going to do this multiplication, 5 times 5, 5 times root 2, and then it's going to be minus root 2 times 5, minus root 2 times minus root plus root 2. And then I'm going to end up with 23 here. Okay, that's the aim. But of course, you have to show the multiplication, right? This expression must be expanded properly elsewhere so that you can, again, write the result here. Now, we said in the previous example that we cannot change this expression, right? So we have to multiply the top part, the numerator, with the same expression. So it's going to be 5 plus root 2 here. All right? So this, you're going to work elsewhere like this. And then you will multiply 3 by 5 and by root 2. So you're going to end up with 15, 3 times 5, plus 3 times root 2, that's going to be 3 root 2. So that's going to be your answer. Now, sometimes you're going to have this number as a multiple of these two numbers, or they can have a common factor. So maybe you can further simplify it. So careful with that. Let me show an example. So suppose that you ended up with something like this: 2 plus 4 root 2 over 2. After your rationalizing the denominator work, your answer comes up like this. So that's what you need to do. You're going to take 2 out, so it's going to be 1 plus 2 root 2 over 2. And you can now simplify this 2 and this one, and you can actually write down an expression without the denominator. So it's going to be 1 plus 2 root 2. Right? So if you end up something like this, which seems as if you can simplify, please do not do this. These are cancelled, so you end up with 1 plus 4 root 2. That's wrong, okay? Instead, take the common factor out and then simplify. All right? This is very important because you have to have the simplest expression if possible. Right. Now, work on these questions, solve them in your book, and submit your answers online. Thank you.